This is a production of Cornell University.
Well, first of all, thanks to Anu and Kathy and many others for the invitation, the opportunity to come here. It's a pretty special visit for me. I don't get back here often enough. Both of my degrees are from Cornell, so I'm here visiting very special people and very special places. Some of them are in the audience. My sister is one of the staff members here at Cornell University who continues to make it a great institution. My wife, the maid of honor at our wedding. I think this is the first seminar my wife has ever seen me give. But we got married at the A.D. Dixon White House just down the road, so it's an incredibly romantic time too. It's great to be here. I really appreciate it. And I do have two full-time jobs. They're at the bottom of the screen. So one is the faculty director for InFACT, and the other is the Kellogg chair. And I'm going to tell you a little bit about the agroecosystems management program first and how we think about agroecosystems and agroecosystem health, because that had a lot to do with the way we shaped our proposal for what became and is becoming the Initiative for Food and Agricultural Transformation. So this is me a few years ago when I was here. This is how I got my start as a scout for the New York IPM programs, scouting cabbage and vegetables across Western New York, first for the IPM programs and then as a private consultant. And I would count bugs and help farmers try to figure out what to do about these insect pests. And I kept asking, well, isn't there a better way that we could be going about this whole thing? And if you start asking those kind of questions, pretty soon you're in a career in research, and that's what happened. And so I continued to work on some of these pests in the earlier part of my career at Ohio State. So this is one of them. This is the Diamondback Moth. That's a pupa. It's in a broccoli floret, and they're a big problem in broccoli florets because you can't wash them out of there. Back in the 80s and 90s, at least, most of your frozen broccoli was coming from central Mexico, the Bajío region. And it led to work with researchers down there where they were setting out pheromone traps for these moths and checking them 3 times a week, every single week, from 1987 to 2005. So as entomologists, we don't get data sets like this very often. And this led to some questions about what is going on in the system that would lead to this kind of pattern. What we showed is 3 kind of distinct periods here where the pattern was changing. So one where there was this kind of regular cyclical pattern. This is using time series analysis. And then a period where the populations increased and the fluctuations got really wild. And then a period where they dropped down again. But the same pattern of how increases follows decreases has been maintained since this drop-off, and this had a little bit more to do with weather than anything else. Well, and what we were finding is in looking at what was going on in this agroecosystem that would best explain what was going on with this particular pest, it was really a lot about the amount of broccoli that they were growing. So they went from 8,000 hectares to 40,000 hectares of broccoli during this period. That's a heck of a lot of broccoli, and what it does is create an enormous carrying capacity for pests like this. But the pest wasn't the only issue. They were starting to have problems with groundwater, with salinization of the soil, with markets, with labor availability, to the extent that the processing companies down there that were part of this industry were already looking at other parts of the world to move and get out of this region of central Mexico. So if you keep focusing on just one problem, then usually you miss what's going on in the system. We have a grand tradition in entomology of solving one problem and creating 3 more in the process. And that's great for job security, but after a while it starts to feel like a game of whack-a-mole, where you just keep going from one problem to the next and fixing that and then moving on to the next one. We like to step back and take a look at the system instead of looking at one problem after the next. Like I say, we have a tradition in entomology of this. We also have a tradition of this in the land-grant system in general, and in our food policy in the United States. So that's kind of wrapped up in this Byzantine proverb, and you notice who brings you this proverb, but he who has bread has many problems. He who has no bread has only one problem. And that's quite true, and we were experiencing that right after the Great Depression. So I was just reading the other night, something like 70% of the young men who joined the Civilian Conservation Corps were malnourished and poorly clothed and the like. When World War II came along, there were a lot of people that were just not fit to serve in the military because they were malnourished. Now you start having trouble raising an army, and governments get attentive to that very quickly. So this was kind of the resolve coming out of that period in our history where there was a decision across government levels. We are not going through those kind of shortages again. We're going to make sure that there's enough. And in the process, we've created a few other issues. So this is the bind that we tend to put farmers in these days, a simple kind of cartoon version of it. But the amount that we all spend on food that the farmer gets to keep over the years keeps shrinking, because our food prices are not going way up, but all the costs of what farmers have to deal with in order to be really productive keep going up. The cost of inputs, the value added beyond the farm gate. So there's a couple ways out of this squeeze. You can get really good at operating in the middle of it, and what people tend to do there is get specialized, expand, get bigger, get really good at using technology so that you can produce a whole lot because you're not making much on each unit. The other approach would be to try to recapture some of the cost of these inputs or some of the value that's added beyond the farm gate. Either way, it's a very difficult task to be a farmer these days. So in the Agroecosystems Management Program, this was a group of faculty at Ohio State University who were willing to step back and work with partners outside of the university on looking for balance. And that's balance between the environmental and the economic and social dimensions of agriculture, and considering it as a system. It's not just farms, it's also neighboring communities. We had a tradition very early on of working with people outside the university because we found if this was a group of academics talking about big systems kind of stuff, it would get very ethereal very quickly. And so we were interested in making sure this was grounded in something that would actually help. And one of the things that we were asked for very early on was, we're talking about this very complex system. It's environment, it's economy, it's social. How do you get your arms around this? Can you give us a way of understanding how we're doing as an agricultural ecosystem? So we set out to construct an index of agroecosystem health. And if you're going to do that, you have to define health first. So we chose this definition that was proposed quite a while ago by Gordon Conway. He was president of the Rockefeller Foundation at the time, and he described agroecosystem health in terms of these 4 properties. And we further fleshed out what we mean by each of those properties, but if you look at those, you could probably see already that they're not necessarily things that are moving in lockstep. There's trade-offs within that list. So it's challenging anyway to talk about agroecosystem health in terms of those 4 properties. We came up with 6 key variables that, to us, describe the processes that best led to a definition of those properties over time. And those key variables were kind of in these 6 broad categories: soils and soil health, topography, biodiversity, and then the next 3 are social economic properties. And the idea behind the index that we came up with is that you have a pattern on a landscape, and you have things flowing across the landscape. Some of it's good, money going to farmers, beneficial organisms. Some of it's bad, so pests and diseases flowing between farm fields. Some of it's just flowing, but it's the pattern of sources and sinks on the landscape that leads to those flows. And it's the flows that define the processes that lead to those properties of productivity and sustainability, stability, and equitability over time. So long story short, we combined those 6 variables, and actually there were quite a few indicators that led to those 6 variables using analytical hierarchy process, combine that into an index of agroecosystem health that you could then map and get an idea of how you were doing and compare one place to another. And even more importantly, where agroecosystem health was a bit lower, you can drill down and figure out why. So what are the underlying variables that you could work on to improve the health of that part of the agroecosystem the most quickly? And that's a little bit of background on how we think about agroecosystems and agroecosystem health. It's this combination of social and biophysical dimensions combined that lead to this pattern on the landscape. Healthy agroecosystems are becoming very important. There are some predictions that suggest that agriculture is going to get harder to do over time. So these are the climate change predictions for our part of the world. That's the upper Midwest. I live right about there in Worcester, Ohio. And in this map on the left, darker blue means more predicted heavy rainfall events. So we're in a part where we're expecting more heavy rainfall events. This one on the right is prediction for increase in consecutive dry days. And once again, we're there where it's a little bit darker. So we're expecting more heavy rainfall events and more consecutive dry days, wetter when it's wet, drier when it's dry, and no predictability so far about what the pattern is. Are we talking about 3 years of drought and then 3 years of rain, or 1 month of drought, 1 month of rain? And until you can figure that out, you really don't have a good way of adapting to that or knowing what you have to do to adapt to that new pattern. So for me, the element that best describes these predictions of climate change is in this row in the periodic table of elements that you usually don't spend much time on in chemistry class, and there's a gap in the middle of them. They all start with UU, the element of surprise. And I think that describes pretty well what we're up against with climate change. Just a lot of surprises, and a lot of them not necessarily real pleasant surprises. So how do you adapt agriculture? I'm not sure how many of you have seen this diagram. This is from the Resilience Alliance, and it's kind of an early version of the figures that they use to describe how systems change over time. And you probably recognize this continuum from R to K, which is kind of the classic disturbed to more conserved kind of climax vegetation. So the ecosystems and social systems tend to go back and forth between these two poles. In sustainable agriculture, a lot of what we do is when we plow a field, we're pushing it back towards this exploitation area because we want to exploit it for food. And of course, we create an environment that pests and diseases and the like can exploit very well. So a lot of sustainable agriculture is trying to strike that balance and getting the system to act more like these conserved systems where we get what we need out of it, but it's not so exploitable by other organisms so that you have these wild outbreaks of pests and diseases. And that's all right, but what happens occasionally is the environment changes to the point where everything that was conserved and working real well here just doesn't work anymore. And it all gets released. And then in that release, see, is that mouse even working up there? There it is. Yeah, so in that release, there's a chance for all of that had been conserved up here to get reorganized and then go back into this cycle again. And in that reorganization, you can actually lose some capacity. So think desertification or something like that, loss of a seed bank. So you no longer have some of that capacity to reorganize. So when we talk about resilience, we're talking about what happens when there's a big change in the environment. Well, these predictions of climate change would be a big change in the environment in which we're currently producing food. So that list of challenges is one that Fred Kirshenman throws at us all the time. He's part of this network of Kellogg chairs and other scholars. You want to talk sustainable agriculture, tell me how you're going to farm with higher temperatures, more extreme weather, half the water, and oil at $300 a barrel. And that would be very difficult to do agriculture the way we do it now under those conditions. So that's the kind of environmental change that'll cause a big shift. Part of the definition of resilience is about how much change the system can go through and still bounce back to where it was. So there's this kind of stability part of the definition. Can it take a shock and go back? What's more important is when the environment really changes, how can the system adapt and get through that, what they call in the Resilience Alliance, the back loop of release and reorganization, and adapt and regain the functions that we're really concerned about, like everybody having enough to eat. So the kind of qualities of a system that make it better able to go through that back loop of release and reorganization are self-organization, the capacity to learn and adapt, which typically requires some diversity that you can then select from in that adaptation. And what kind of qualities would we look for in agroecosystems then? Well, there's diversity in terms of what we produce. And if you go to markets in other parts of the world, you'll tend to find a whole lot more things that people are eating than what you'd find at Wegmans. There were probably a whole lot of things that people were eating in this area that we're not consuming anymore that people were eating before European settlers arrived. So there's a whole lot of things out there that we don't necessarily consume that we could. We could be thinking about that. You can be thinking about the diversity within the things that we do eat. So there's the phenotypic, genotypic, and gene by environment interaction kind of diversity that you have within crops of a given crop. And then there's diversity in terms of who's doing agriculture. Right now it's down to about 1% of our population that are on big farms, but a lot of people getting interested in getting re-engaged with agriculture. So that would give you some diversity once again. And if you think about it, those qualities, especially with self-organization and innovation, is some of the things that link these dimensions of agro-ecosystem health. It's very consistent, this idea of agro-ecosystem health leading to resilience. So there's some ideas about that published in a paper in JESS if you're interested in those kind of questions. So this has kind of given us a lot of guidance on the kind of work that we're doing in the Agro-Ecosystems Management Program. This is an example of a small and mid-sized farms grant that we have. This is a small farm just to the west of Worcester that was donated to OARDC. We have a grant to look at the very early stages of diversifying a farm that's been in corn and soybeans, not big enough to really make a living doing corn and soybeans. So if you're not going to do that and do economy of scale, then what are you going to do? And economists are calling this economy of scope, the idea that you diversify and then use the diversification as a way of recapturing some of those input costs that you would otherwise be spending if you were going the other route into economies of scale. So we've got oilseed crops, forage, vegetables, pasture poultry, all kinds of things going on there. And what we're looking at in this project is how quickly are the new benefits in terms of soil quality, access to markets and things like that, as well as new costs cropping up. This is a project that we've had for some time. The idea of this social networking site is connecting entrepreneurs along supply chains so that they're launching entire supply chains instead of just one business in the middle of a non-existent local or regional supply chain, which is kind of tough to hang on while you're doing battle with Walmart, waiting for everybody else to show up. So the idea is, well, let's get the planning going more in cahoots and launch the entire chain. And it has features on there for entrepreneurs to connect with each other along supply chains, collaborate on their business plans. There's a sneak peek at the next version of it, so we're just about to launch this. And this has sections for both the bloggers who want to share deep thoughts about food, which is great. They could be investors at some point. But then you have the entrepreneurs, and they're the ones that are really what the site is about, is helping them develop plans that lead to entire supply chains, as well as a section that's for economic developers. So it becomes their tool that they can use to support that entrepreneurship, which really is their job. But agriculture is a tough place for economic developers to work, because you're talking about lots and lots of businesses, and they're spread out all over the place. So here's one example of one of the supply chains that was evolving as part of this project. This is a very large dairy farm up in Ashtabula, Ohio. That little silvery thing down at the bottom is not the swimming pool. That's called the lagoon. It's not something you want to get into. So this dairy farmer needed a way of dealing with the stuff in the lagoon. And his choice, he got involved with talking about a biodigester with a company called Quasar. And this is a biodigester they have on our campus at OARDC. And that would give him a place to put the cow manure. That would generate heat and methane. So he's got a lot of cows. He's already got heat and methane. He doesn't care about those products. He just wants to get rid of the manure because he needs that to get his siting permit. But there was a small vegetable grower down the road who wanted to site a greenhouse next to the biodigester, use the heat and methane to grow vegetables all winter. He already had a contract with the local school system, and they were willing to collect their food waste and send it back to the biodigester. And you need to combine food waste and manure actually to make the biodigester work really well. So that's a good example, kind of classic industrial ecology, where that output from one business becomes the input for the next business, and it all cycles very efficiently on a landscape. And those are the kinds of flows that we had envisioned many years ago as being the kind of flows that would lead to healthy agroecosystems. Full disclosure, this never actually happened. The negotiations broke down between the dairy farmer and the biodigester builder. So they never could quite get it together to put all this in place, but it's a great idea. It's waiting out there. So if any of you have a biodigester and know any vegetable growers. It's still waiting to happen. So to really understand what we've got on the Ohio landscape, you have to go back in time, like well before we developed the Agroecosystem Health Index, about 1.8 million years. And that takes you to the end of the Pleistocene, which is the last time Ohio was extensively glaciated. So that dark area at the top is the glaciated area of Ohio. That river, the Taze River, was, boy, that mouse just doesn't want to do it. This here was what paleogeologists say was the drainage before that ice age. Came up from the southern Appalachians, arced through Ohio, and then down the Mississippi. And what the glaciers did is kind of bulldozed all of this rich glacial till into those deep river valleys and created really productive, fertile soils, and also rearranged the drainage so it's now what you'd recognize as the Ohio River going down to the Mississippi. I have to sheepishly admit I don't remember this from the geology course that I took here, but I think that was the same time that the Finger Lakes and the kind of glacial geology. So you've taken the course more recently, haven't you? No, but okay. So we took a walk in Robert Treeman yesterday, and I do remember taking the walk in Robert Treeman with the professor in that course and hearing all about this in terms of gorges and Finger Lakes. So anyway, this is what was happening just to the west. And what it led to is a real opportunity for people in this state. So that's the Glacial Divide. Just keep your eye on the line between the glaciated and unglaciated. And that is median household income in 2000. Yeah. Let me do that one more time. So keep your eye on the line again. So if there's any question that our wealth is coming from our soils, that helps me get to ask that question. These are very fertile, productive soils. Also leads to a state with a lot of diversity. So that's a Gordon Vegetation Index map. And I don't expect you to read the legend, but the point is there's a lot of different kinds of plant communities in Ohio. We straddle 4 EPA ecological zones. So there's a tremendous amount of diversity. So fast forward a few million years to about 1800, and this is what European settlers are finding. So Columbus is right there, the Ohio River's down here, this was kind of prairie, this was all woods. The early settlers figured the prairie was kind of useless because you couldn't even grow trees there. But what they figured out very quickly is these river valleys were really good for growing corn. So this is the Scioto River, this little finger coming down here to the Ohio, and they figured out real quickly you could grow a lot of corn in those river valleys. So it's 1800 or 1810. You got a lot of corn. What are you going to do with it? There's nobody around. It's the Ohio frontier. There's maybe 2 military garrisons along the Ohio River where you could sell it. What are you going to do with corn? Anybody got an idea? Give it legs. Yeah, feed it to cows. So a guy named William Renwick in 1813 figured out that you could make a tidy profit by producing corn-fed beef and sending it over the mountains and selling the beef on the international market out of Baltimore. And we had a 1,500 head CAFO, confined animal feeding operation, in Coshocton in 1815 in Ohio. So what else can you do with corn? Anything? Yes, ferment it. So there were stills all over the Ohio frontier, not because it was perpetual spring break. It was because that's something you could do with corn to add value. So you could turn it into whiskey and put the whiskey on flatboats and float those down the Ohio River to New Orleans and sell it on the international market. And then you could also take the brewing grains and feed that to animals, pigs and the like. So there were 2 distilleries and about 9 breweries in Cincinnati turning the corn into ethanol and then taking all those brewer grains and feeding them to pigs, which you could also chop up and put in barrels with a lot of salt and sell that on the international market out of New Orleans. I love these quotes about what life was like in Cincinnati back in those days. It was called Porkopolis. And that bottom quote is perfect. Cincinnati originated and perfected the system that packs 15 bushels of corn into a pig and packs the pig into a barrel and sends them over the mountains and over the ocean to feed mankind. All right, so that's 1820. And we fast forward to about now. Well, first, that's a statue of a flying pig. There are those statues all over Cincinnati. This is College of Biological Sciences. We can't let that go without addressing it. So this is the Lord Brabazon of Terra, the first Lord Brabazon of Terra, who demonstrated in 1909 by strapping a basket onto the wing of his biplane and then putting a pig in the basket and then taking off into the sky that pigs do indeed fly. This is back when the ruling class not only approved of science, they actually got involved in it, testing hypotheses like this. So the bystanders tended to say that the pig didn't seem to have a lot of choice, but the pig did fly. So this is what you see these days if you look at Ohio from space. So remember the Gordon Vegetation Index map. We can grow all kinds of stuff. We grow all of the things on this long legend somewhere, but you see 5 things. And you can see that line of where the glaciers were again. And all that stuff on the lower right is grass and trees, and on the upper left, it's corn, and we've added soybeans. So that's what we've accomplished in about 200 years. We've added soybeans. We're still growing a lot of corn. We still feed it to animals in CAFOs, and we produce meat, and we sell that on the international market, and we produce ethanol for transportation fuel. There is one other thing that's changed in this picture, though. All those gray spots, that's where people live. So we're not in the situation the settlers were faced with in the early 1800s. There actually are some people around that you could sell stuff to, and people are starting to figure that out. But if you go out, why does it look like this then? You know, if you have all these local markets right there and you're still producing corn and soybeans everywhere, what's the deal here? And if you talk in the farm community, there's a lot of focus on, we feed the world. This is what we have to do because we feed the world. And I have a lot of respect and admiration for people that are driven by that goal. We want to feed somebody. We want to feed the world. And that's a great thing, but the data isn't necessarily lining up with that statement. So if you look worldwide, it's approximately 1 in 9 people chronically malnourished with all the disease and lack of human potential or decrease in potential that comes along with that. It's not because farmers aren't producing enough. So if you look at, these are FAO statistics, by the way. If you look at per capita food availability, about 2790 kilocalories per person per day. So I think it's calories actually. So how many calories does it take to sustain a person for a day? 2,500, 2,000? On who, yeah, and how. So if you're Michael Phelps, it's a lot more. Don't try to do what he does. But it's bottom line is that's more than what it takes to really maintain each person in terms of caloric requirements. So it's not because there isn't enough, it's because obviously it's not getting to people who need it. And another interesting statistic is that people think that this all comes from these really large farms because they're really efficient, they have really high yields. It turns out 70% of the supply is still coming from small farms. And even though large farms have a lot of the land area, it's not the majority of the food that's being produced. So these are kind of global figures, the 1 in 9. We own it in Ohio. So this is the most recent census. It just came out several weeks ago. We've now been joined by Maine and Oregon as northern states with higher than national average household food insecurity rates. But the census before that, we were the only one out of the South that had higher than national average food insecurity rates in Ohio. So it's about 16% of households. That's 1 in 6 of our neighbors experiencing low food security. 6.6% very low, and we'll get to that in a minute, but it goes way up for households with children, single mothers, people of color, the same kind of categories that are affected by kind of class issues and poverty. So this is not the picture of a system that's sustainable or resilient. This is what's where those low and very low food security figures come from. So the darker, the middle shade of blue is low food security. It's those top 3 categories. So worried, kind of all the stress of not knowing where your next meal is coming from, plus a change in the diet, so don't feel like you can't afford a balanced meal. Very low food security, you start getting into actually going hungry. But even for low food security, that's 1 in 6 of our neighbors, there's an impact on what people are eating. And it's not just the hunger and lack of food that's a a food system issue. So that obesity, type 2 diabetes, diet-related disease is a huge food security issue. We know that a lot of what's marketed for children is not great nutritionally. So that there's actually more people that are experiencing obesity than chronic hunger and malnutrition these days. And that is a food system issue. The current statistics are that a lot of volunteers for the military are being rejected because they're obese. So once again, we're back to having trouble raising an army. So the US government is starting to pay attention to this pretty seriously. And then you have these predictions of serious food shortages across the planet by 2050. So it's questionable whether we've even solved that one problem, but we've certainly, that one problem of he who has no food has only one problem. He who has food has many problems. We have enough calories. We've still got some issues. So these are some of the issues that the Ohio State Discovery themes are meant to have an impact on. So the three discovery themes are energy and environment, health and wellness, food production, and security. If you look at, sometimes they're called grand challenges, challenge themes. They come by different names in different universities. These are not unique to Ohio State. You'll find those themes elsewhere. But these are the three that our trustees back in about 2010, several years ago, figured were themes that Ohio State had strengths to resolve. So they were willing to put some resources into those strengths. And Anu tipped you off on the amount that's being invested. There is this new source of revenue at Ohio State, and it's because someone in the business office figured out that we're a university, so why are we screwing around with managing parking lots? And there are a lot of parking places on the Columbus campus, about 35,000 of them. So running the parking lots is kind of a big effort. They figure, well, let's lease that to somebody else. Let them do the parking lots. We'll focus on research and education. So they leased it to a company from Australia for $485 million over the next 50 years, which is a big slug of new resources. And someone else in the provost's office said, you know, you should tie that to faculty salaries. So there was a decision, because faculty are revenue generators, so that's the route that we go. And then we had a provost who was also very willing to make this very bottom up. So from the very beginning, it's been, you know, faculty, you tell us how you want this to work. Started with faculty advisory boards and laying out what are the sub-themes within those big three that we might actually be able to address at Ohio State. And then we did the cluster analysis, and they kind of clustered into data analytics, food for health, materials and energy, and then infectious diseases. So there were calls for proposals in each of those. And I led a group around climate and the environment on developing a framework for data analytics. And then the next round of proposals came out on these other three themes. And together with about 50 faculty across the university, we came up with a proposal for food security. Just going into some of the questions Anu was asking, this was a result of about 20 years of reaching out across the university through the Agro-Ecosystems Management Program and developing relationships with people in other colleges. So when we put out the call for the email, does anybody want to get together and talk about this? We had people showing up from many different colleges that we already were working with. So people in the Department of Art, the Knowlton School of Architecture, Glenn School of Public Affairs, College of Social Work. So it was a very diverse group that showed up on the table and developed this proposal that became InFACT. And this is the vision and approach, that we become a worldwide leader in conceptual models, but also practical examples of a transformed food and agriculture that leads to secure, equitable food security for all. That we start with the food system that we own at Ohio State University, because we own one. We have depending on who you talk to and which day, somewhere between $30 and $39 million annual food bill between student dining, the medical school, all the ways that we procure food at Ohio State. It's going to take collaboration across the sciences, engineering, and humanities, as well as outside of the university with many partners outside. It takes a holistic and transformative approach. This is not tinkering and solving one problem after the next, the whack-a-mole game. This really is taking a transformative approach. And it does start with the 30 new hires. Now, another interesting little sidelight is when we were given the go-ahead to proceed with InFACT, it was a go-ahead on these 30 hires. So we had proposed that we're going to start with our own food system, and we're going to change our campus landscape. Nobody was putting us in charge of campus dining or the campus landscapes and the like. So since then, just last year, there was a set of sustainability goals set by the university, one of which was increase the production and purchase of locally and sustainably sourced food to 40% by 2025. And the provost and vice president for student life commissioned a panel that's now being chaired by myself, our executive director, the head of dining services, and a student to figure out the action plan. So we actually do have our hands on the Ohio State food system now and can make that part of this initiative, as well as the kind of research and teaching and outreach that these new faculty colleagues will be pursuing. So 5 main areas where we're doing this hiring of the 30 hires. One is in climate resilient food production. And it's actually not just production, it's also the processing, the preservation, the distribution, the logistics. So it's that entire food system from the soil to the plate. And it's not just about changing a particular system, it's thinking about diversifying that entire approach. So here's a good example. This is Kojo Ababio, the guy in the center there. And he's one of several people I've met who just decided, you know, this food system doesn't work for our neighborhood, so the heck with it, I'm just doing my own. And so he started clearing off vacant lots, getting the Somali youth in the neighborhood to help with it, producing collards, African basil, selling and preparing it and selling it in the New Harvest Cafe, which is behind that mural. And these are some of my students trying to keep up with him. He's a very energetic guy. And so it's about, you know, how do we diversify any given system and across systems of production and the rest of the food chain. There's a medical and nutritional and health dimension to this. So the medical community is embracing this idea that food is health. I don't know where they heard that, but this is a garden that's being developed by one of my colleagues in the medical school, the School of Health and Rehabilitation Science, for cancer survivors. And what she's doing is checking the biometric stats on the cancer survivors that are out there working in the garden, putting numbers behind this idea that this actually is really good for you to get involved in this kind of thing and shift your diet and to be working outdoors, producing food and sharing it. So there's the nutrition and health. There's the policy dimension, because policy does shape how our school system or our food system works. So this is a site maintained at the Glenn College of Public Affairs, a colleague, Jill Clark, who's done a great job of holding local food policy councils together in Ohio. Since we had a state food policy council, haven't had it since the last administration came into power. But we've been pulling together this group of many local councils into a statewide coalition. There's an entrepreneurship and business opportunity to all this. If you're going to develop new local and regional supply chain, there's an opportunity for new businesses. And this was a study done by the Bush Consulting Group for the Fund for Our Economic Future in Northeast Ohio, where they identified that both in terms of jobs on the left and revenues on the right, what you could get out of the agricultural biosciences, so it's agriculture writ very broadly, is much greater than some of these other areas like advanced energy, industrial water, flexible electronics that people were kind of gaga over because they're high tech. And that top part of the bar, after the big thick bar here, that is import substitution. So it's basically producing in Ohio what otherwise we would be importing. It's an enormous economic opportunity. So entrepreneurship and business are part of it. And then finally, culture. And that's why it's a capital C in agriculture, because this food is very basic to our culture. I've done this exercise of asking students, you know, reflect on your experience with food. And invariably, it very quickly gravitates to special occasions with family, often religious holidays. So that is culture. there's a cultural dimension to this. The top left picture is worldwide. There are many different approaches to food in different cultures. The bottom picture is actually Columbus Public Health Market. So we have a very diverse community in Columbus, Ohio, as well as in a lot of the United States. And at the end of the day, it's what are these kids experiencing and how are they going to grow up thinking about food and food systems. So those are the 5 broad areas. These are the position descriptions or the position titles. Wherever there's a Buckeye, there's somebody already hired. 6 of those are already on campus. So everybody but this one, she arrives, Ingrid Adams arrives from Kentucky on December 1st. All of the green circles are searches that are underway. The yellow ones are positions that are kind of chundering through the approval process, and the white ones are the ones that we've still got a little bit of work to do. And the deal here is the Office of Academic Affairs is providing half of the salary for each of these positions. The other half has to come from the Department of College that person's going to be in. A lot of new partnerships being built here. So this Food, Health, and Human Behavior is College of Medicine, but the person's actually tenured in extension. It's never happened before. This Agroecosystems Management is going to be shared between the Department of Horticulture and Crop Sciences and Animal Sciences. We've never had a position shared between those 2 units before. So we are pushing the culture within the university. And to me, that's one of the most important things here. We got together as a group of faculty across 10 different colleges and came up with these ideas. And now we're going to departments. That's completely different from the way it has worked for my entire career at Ohio State. It's always been strictly within a department. And I've checked with our administrators. We think this is right. That's the last time we got together and talked about who we were going to hire and why as a faculty across the university. Actually, these are not faculty. Those are students. This is actually the first graduating class at Ohio State, and that's a very famous stereoscope photo. So it's the deal where you put the thing in there and you can look at it, one out of each eye, and it comes to 3D. So anyway, but it was a long time ago. That was about 1870. And this is just the first step, the hiring the people. The next step is weaving the network. So we've actually envisioned the network that we would expect between departments, interdisciplinary programs, external partners for all 30 of these people. So that inner ring is the 30 new hires. And all those lines, if you can possibly follow them, is the network that we would expect initially. And it'll be interesting to see how the network actually develops. But that's the next real chore for me as faculty director. So that's the handbook that's on my desk these days, the network weaver. June Holly is right down in Athens, and this is a real innovator in network weaving. I'll just give you a real quick sample of one of the projects that's emerging, because I'm involved in this one. But we have a linkage and leverage grants program. So linkage is how many people can you connect. Leverage is how well can you use it as a seed for new resources coming in. And those are on our website, which you'll see in a minute. Yeah, I'm almost. So here's the food mapping team. We did a study in the Gulf Coast counties of Mississippi where we looked at what's the cost of a representative low-cost balanced diet, the USDA Thrifty Food Plan, as a function of where you live. So it's the cost of all the items in the USDA plan as well as the cost of getting around to round it all up. And that changes as a function of where you live. That's the map. It's about a 2-fold difference. If you don't have a car, it's about a 4-fold difference. And we did this because I've never really liked this idea of food deserts, that there's a line here and it's a food desert there and it's not over here. You have these places where it's a very gradual transition in increasing cost. And the point is that we say very blithely, food is cheap in America. Well, it depends on where you live and who you are. And the real interesting part that we're going to repeat the study in Columbus to get at this is what's the median income for people in those areas that are in red, and how big a percentage of their income is it? The other project that we're working on, in addition to doing that foodscape in Columbus, is new faculty hire in the data analytics initiative who's doing an agent-based model of people, how people actually respond to that landscape. And of course, they cut corners. It affects the diet. And we have colleagues in the medical school who can get from diet to what are the health outcomes. So if you're talking about the answer is a new grocery store somewhere or a new bus line somewhere, you have a way of predicting who is that going to help and how much and what's the health outcome going to be. So that's a flavor of the kind of research that we're pulling people together to do. That's the website. We've hired Bryan Snyder as our executive director, and he's just starting. And I better stop there and take some questions if there are any, but I'm around tomorrow as well, so I'd be glad to get together with you and pursue this further. Thanks again.
So Columbus, where your main campus is located, the Franklin Park Conservatory has been running the Growing to Green program to encourage the establishment of community gardens, especially in under-resourced communities. Will your program have any relationship with that Growing to Green?
Yeah, we already do. With Growing to Green, with Mid-Ohio Food Bank, Children's Hunger Alliance, Columbus Public Health, there are quite a few partners, and they're really the ones that can help. One of the things that we have a pending proposal that would allow us to take this new purchasing that Ohio State is willing to do and direct it at the community and get people help in getting into production, if that would help with their family situation. And I'm not worried about whether it's full-time or part-time. I think part-time is actually just fine. But to do that, those folks are going to need a lot of support, training, learning how to do it, things like that. We have a tremendous number of community partners that can help with that sort of thing. So yeah, absolutely. And that, we talk about agricultural transformation. Transformation, we can help encourage it from the university with research and education, but the transformation happens outside. With the exception of the one food system that we do own, that is the only, so that's why we're starting there. Question. We have questions up in Geneva. Sorry, we have a tradition of doing it this way in Worcester. Yeah. We recognize those guys don't necessarily get to raise their hand. Was there a question?
Yeah, Casey?
Yeah.
What's your vision of Ohio State 20, 50 years down the line for the food systems?
Okay. That was my graduate school advisor, by the way. And we're right back to the exam. So Tony asked, what's my vision for the food systems programs at Ohio State 20, 30 years down the line? I'd like to see this initiative grow. I think there's an expectation that it becomes part of the formal structure at Ohio State University. What's more important to me is that it becomes part of the culture at Ohio State, that we continue this tradition of getting together across colleges to talk about who we hire, why, and how we can progress on some of these really big challenges. And also how we partner with the people outside the university who are really the agents of change out there. So that would be my vision, is that this leads to a transformation in the way we operate and a transformation out in food and agriculture.
So what are the hurdles to get to that vision? What are the hurdles both domestically and internationally?
Yeah, I would say the hurdles are many, and they would be in each of those 5 dimensions that I mentioned. So there are hurdles that have to do with how do you gain new economies in production, not just economy of scale, but economy of scope. How do you, things like we have a strong group in precision agriculture. So how do you take that technology and make it scale independent? So it's helping farmers across any different scale. One example of the kind of research that would be needed to get to that vision. So there's, I think, hurdles there, hurdles in the health fields, policy, the business and entrepreneurship, and how the private sector engages with this. And then finally, culture. How is it that we have 16% low household food security in Ohio and nobody knows about it and nobody's out screaming and demonstrating in the streets about this? So there's a cultural dimension and a cultural hurdle to overcome on this, both here and internationally.
Casey, I'm really intrigued by the inclusion of arts and architecture and sort of thinking beyond our sort of traditional partners in the ecosystem. How did you engage them, or how were they brought into the fold, and what is it that how are they changing the way you're looking at these questions?
Yeah, great question. Because I've been working with folks in landscape architecture in particular, and city and regional planning, which is also in the School of Architecture, and those folks are, very interested in this question of how do you plan for an improved food system, in planning a community. Landscape architecture, designers tend to look at these things in a very holistic way, but a completely different holistic way than I look at them. So I already gained something from talking to landscape architecture or landscape architects in how they're designing, but they design around very similar principles to what we're talking about in designing agricultural production practices and things like that, where they're building in the ecological and the economic and social dimensions of the design and needing to understand that. I was in a design charrette last week in landscape architecture on adaptive agroecology. And this is one of our new hires. Her name is Forbes Lipschitz, and she came from LSU. She's featured this month on the cover of Landscape Architecture magazine for work she was doing in catfish farm. And she works at these very broad agroecosystem scales and is interested in visualizing what new agroecosystems might look like. And what do they look like now, and where are the opportunities to start changing things? So this design charrette, I asked in the middle of it, have you guys all had ecology? Because you're really doing a good job of bringing those principles in. Most of them actually have not had a course in ecology, and it becomes the reading that they have to catch up on very quickly. So I think that's an example where we have something to contribute to what they're doing in landscape architecture. They're very quick to reach out to us to help, especially with that part of it. But then they also come up with these ideas and visions and ways of visualizing it that are not in our skill set.
Thank you, Dan.
Thank you.
So much.
This has been a production of Cornell University, on the web at cornell.edu.